Gravitational potential energy. If an object has been lifted against the force of gravity, the energy it stores is called gravitational potential energy. The crane does work in lifting the load. Energy is provided by the crane's motor. This energy is stored as gravitational potential energy of the raised load. The greater the weight, the greater the potential energy. The greater the height, the greater the potential energy. On Earth, the strength of the gravitational field is about 10 newtons per kilogram. The load has a mass of 400 kilograms. The force acting on the mass due to the Earth's gravitational field is given by force equals mass times gravitational field strength equals 400 kilograms times 10 newtons per kilogram, which equals 4,000 newtons. We call this force the object's weight. On Earth, the strength of the gravitational field is about 10 newtons per kilogram. The load has a mass of 400 kilograms. The force acting on the mass due to the Earth's gravitational field is given by force equals mass times gravitational field strength equals 400 kilograms times 10 newtons per kilogram, which equals 4,000 newtons. We call this force the object's weight. Work is done when a force moves an object through a distance. We can calculate the work done on the object by using the equation work done equals force applied times distance moved in the direction of the force. In lifting the load, the crane must apply an upward force equal to the weight of the load. The work done by the crane is given by work done by crane equals weight times vertical distance equals 4,000 newtons times 5 meters, which equals 20,000 joules. Notice that the work done is measured in joules, which is the same measurement unit as for energy. Whenever work is done, energy is transformed from one form to another. The electrical energy supplied to the motor of the crane has been transferred to gravitational potential energy of the raised mass. A 2-kilogram rock of weight 20 newtons falls off the top of a cliff onto the beach below. If the cliff is 20 meters high, how much gravitational potential energy is lost by the rock? Gravitational potential energy transferred equals weight times vertical distance, which equals 20 newtons times 20 meters, equals 400 joules. If all of the gravitational potential energy is transferred to kinetic energy as the rock falls, what is the speed of the rock as it hits the beach? Half times mass times speed squared equals kinetic energy. Half times mass times speed squared equals 400. Half times 2 times speed squared equals 400. Speed squared equals 400. Speed equals the square root of 400, which equals 20 meters per second. An astronaut on the moon lifts a rock of mass 200 kilograms. If the strength of the moon's gravitational field is 1.8 newtons per kilogram, the weight of the rock is weight equals 200 kilograms times 1.8 newtons per kilogram, which equals 360 newtons. If the astronaut lifts the rock 2 meters, how much gravitational kinetic energy is transferred? Gravitational potential energy transferred equals weight times vertical distance, which equals 360 newtons times 2 meters. This equals 720 joules.